Betelgeuse, a celestial object that has fascinated astronomers and enthusiasts alike, presents a captivating mystery in modern astrophysics. Its designation as a red supergiant situates it at a crucial stage in stellar development, a phase that signals the end of a massive star's life cycle. This stage is marked by significant changes in the star's physical properties and its ultimate fate, which could profoundly enhance our understanding of stellar processes and cosmic phenomena. The developmental path of a red supergiant like Betelgeuse involves substantial changes. Such stars have advanced from earlier stages of stellar life, progressing through the main sequence and giant phases. These stages are characterized by the star's core fusing hydrogen into helium, and as this fuel depletes, the core contracts, while the outer layers expand. For Betelgeuse, this results in an enormous, swollen outer envelope and a core that becomes increasingly unstable. The core of a red supergiant like Betelgeuse eventually becomes so dense that it begins to fuse heavier elements such as carbon and oxygen. This fusion process generates tremendous energy, causing the star's outer layers to expand even further. However, this phase is relatively brief on cosmic timescales, and as the star continues to burn through its nuclear fuel, it reaches a critical point where it can no longer support the weight of its outer layers. This leads to the core's collapse, resulting in a supernova explosion. The conditions leading up to a supernova are incredibly complex for Betelgeuse. The variability in its brightness and the recent extreme dimming are key indicators of the processes occurring in its outer layers. Changes in luminosity can be associated with alterations in the star's outer envelope or interactions with its surrounding environment. Such fluctuations might also indicate that the star is undergoing internal reconfiguration in preparation for the eventual collapse. Moreover, studying Betelgeuse provides a rare opportunity to observe a star on the verge of a supernova. By analyzing its light curves and spectral data, scientists can gain insights into the mechanisms driving its instability. The James Webb Space Telescope, with its advanced observational capabilities, is particularly well equipped for this task. It offers unprecedented resolution and sensitivity in observing the infrared spectrum, allowing researchers to peer through the star's dense outer layers and study its internal dynamics. Another important aspect of studying Betelgeuse involves understanding the broader implications of its impending supernova. When a massive star like Betelgeuse explodes, it releases a tremendous amount of energy and material into space. This explosion disperses heavy elements synthesized in the star's core, enriching the interstellar medium with elements essential for the formation of new stars and planetary systems. These supernovae also produce neutron stars or black holes, depending on the mass of the remaining core. The impact of a supernova on its surrounding environment is considerable. The shock waves from the explosion can trigger the formation of new stars by compressing nearby gas and dust. This process, known as supernova induced star formation, can lead to the creation of a new generation of stars and planetary systems. Additionally, the energy released can affect the dynamics of the galaxy, influencing the distribution of matter and the evolution of galactic structures. From an observational perspective, the imminent explosion of Betelgeuse offers a rare chance to witness a supernova event in real time. Historically, the study of supernova has been limited to observations of past events. For example, the supernova SN 1987A in the Large Magellanic Cloud provided valuable insights into the nature of supernova and their aftermath. However, observing Betelgeuse's transition from a red supergiant to a supernova would allow scientists to study the events precursors and dynamics up close beyond. The scientific significance, the potential supernova of Betelgeuse also holds a certain degree of public fascination. The star's brilliance and its dramatic end are compelling topics for both amateur and professional astronomers. Educational programs and media coverage of Betelgeuse's evolution serve to inspire interest in astronomy and space science among the general public. As a result, Betelgeuse has become a symbol of the dramatic and often violent processes that govern the life cycles of massive stars. As researchers continue to monitor Betelgeuse, they are using various other observational techniques to complement data from the James Webb Space Telescope. Ground-based observatories such as the Very Large Telescope (VT) and the Grand Telescopio Canarias (GTC) provide additional data that helps refine models of the star's behavior. These observations are essential for constructing a comprehensive picture of Betelgeuse's current state and its imminent future. The study of Betelgeuse and similar stars also contributes to our understanding of the broader universe. By analyzing the life cycles of massive stars, scientists can gain insights into the formation and evolution of galaxies. The processes governing stellar evolution are intricately linked to the dynamics of galaxies, influencing everything from star formation rates to the distribution of elements throughout the universe. Furthermore, research into stars like Betelgeuse helps refine our models of stellar nucleosynthesis, the process by which elements are formed within stars. This knowledge is crucial for understanding the origin of elements in the universe and their distribution across different cosmic environments. It also informs our understanding of the conditions that led to the formation of our solar system and the elements that constitute the Earth. In summary, Betelgeuse is more than just a captivating star. It is a pivotal subject of study in astrophysics. Its potential to become a supernova offers a unique opportunity to explore the final stages of stellar evolution and the impacts of such explosive events on the universe. As researchers continue to investigate Betelgeuse, they contribute to our broader understanding of cosmic processes and the dynamic nature of the universe. The insights gained from studying Betelgeuse will undoubtedly enhance our knowledge of the cosmos and continue to inspire both scientists and the public alike. Anticipating that lines might be removed, the most fascinating star I can think of is one that could be astonishing in our sky. Betelgeuse, this formidable entity or bug, exists as a red supergiant star. If placed where the Sun is, it would extend to the orbit of Jupiter. It is colossal, highly unstable, and on the brink of exploding. The universe doesn't function solely through dramatic events like the most feared cosmic bursts, which could profoundly alter all that we observe and don't yet comprehend. Nevertheless, Betelgeuse is recognized as a red, exceptionally massive star that is in many respects larger than our Sun. Brian Cox and other astrophysicists suggest it could go supernova at any moment. People are generally anxious about what might happen since the James Webb Space Telescope is capturing stunning images of the star. When exactly will Betelgeuse become a supernova, and how significant will its impact on Earth be? Let's delve into this further. A star in the constellation Orion shines so brightly that even ancient civilizations have observed it. The forthcoming star Betelgeuse is situated on the eastern shoulder of the constellation. Betelgeuse is the second largest star in the constellation, and its name reflects this feature. The massive shoulder. It is perhaps one of the most luminous stars in the night sky. Besides its brightness, the star exhibits a curious shade of red, which, as we'll see, is quite significant. We have had considerable awareness of Betelgeuse for some time. A Greek astronomer named Tau also studied it. During that era, the primary thing people knew about stars was their color too. Noted that Betelgeuse was orange. Recently, astronomers have been examining the star more closely and now have a clearer understanding of its characteristics. One notable feature is that the star's brightness fluctuates significantly with a variability of 0.6. Betelgeuse is a Vari star, meaning its brightness changes over time. However, recent findings have revealed new data about the star. In 2019, specialists first observed Betelgeuse displaying unusual behavior. Although Betelgeuse did not entirely cease shining, it became markedly dimmer, showing a magnitude of about 1.6. Specialists quickly began investigating why they were witnessing the 10th brightest star in the sky behaving strangely. They had to issue a cautionary statement based on their analysis, which highlighted the unexpected signs the star has recently exhibited. Researchers believe Betelgeuse might go supernova imminently. Brian Cox, a prominent scientist who made this alarming prediction as a professor of particle physics at the University of Manchester, is not joking. He also has a science show, writes popular science books, and holds the position of Royal Society Professor for Public Engagement in Science. Brian describes Betelgeuse as a in-time bomb potentially ready to explode at any moment, compounding the concern. The James Webb Space Telescope has provided substantial evidence to support this claim. What unusual signals has Betelgeuse given that have caused such alarm in astrophysics? Based on new findings, Betelgeuse has been classified as a supernova candidate, yet researchers remain uncertain about the exact timing of its explosion. The fact that Betelgeuse is many times the mass of the Sun is one reason for this classification. A star must be several times the mass of the Sun to be considered a supernova candidate. The situation becomes even more intriguing as analysts have used various instruments to study Betelgeuse, including the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to explore what is happening in space around Betelgeuse. Their discoveries are still fascinating. The Sun was born on August 31st, quite some time ago. During that period, Betelgeuse was likely emitting strange signals that made its future uncertain. What did they find? They could detect unusual light waves coming from or toward Betelgeuse, which is highly peculiar, but this wasn't the only thing researchers noticed about the star. This brings us back to the idea that Betelgeuse is a star whose brightness fluctuates. Sometimes it was observed to dim at regular intervals and exhibited dark spots similar to our Sun today. However, the scenario is different. It shifts too quickly, making it a source of considerable interest. Could these indicators suggest that the star is on the brink of explosion? Analyzing how stars evolve is essential to understanding the universe and the various stages of stellar development. There is only one viable conclusion that can be drawn: the star is unstable. Recent data from the James Webb Space Telescope reveal that the star's brightness changes daily. Scientists are fully aware of this, but find it unusual for the star to reach a point where it cannot be stopped. A theory has been proposed to explain Betelgeuse's dimming. The European Southern Observatory specialists suggest that the star is emitting an unusual amount of light. It seems Betelgeuse might explode any day now, which is a primary cause for concern. Researchers studying Betelgeuse have noted that while the star will not reach its explosion tomorrow, the days are numbered. The truth is that stars undergo various phases of change as they approach the final stages of their life cycle. For Betelgeuse, the end is imminent. When the explosion does occur, it will undoubtedly be a remarkable spectacle. The James Webb Space Telescope has provided some surprising data on Betelgeuse, revealing that the star is nearing the point of no return. According to Webb's research, this star could potentially brighten to such an extent that it will be visible in broad daylight while the exact timing remains uncertain. It is crucial to stay informed about its developments. As Betelgeuse approaches this critical juncture, it serves as a reminder of the dynamic and unpredictable nature of the universe.